Hi, this is Mrs. Grizafi. We're on 11.01. So we're starting a brand new unit. It's our last unit. It's on limits, which is a really fun topic and will help you a lot if and when you take calculus. So just kind of looking at a basic approach to limits today. So we're looking at them graphically. We're going to look at them using a table. And then at the end of the lesson, we'll talk about another method using substitution. So the definition of a limit says that if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, the limit of f of x as x approaches c is L. So very confusing, and I think when we look at the graph, it'll make a little more sense to you. So here's how we write it. You write the limit is LIM of f of x, and right down here, you see how it says x and then it moved. X as the little arrow, C, and there's a negative up here. That negative means that you're coming from the left side of C. So we're getting closer and closer to C as we approach C, getting closer to C from the left side. If there's a little plus sign here, that means that you're coming from the right side. And if there's no plus or minus, it means it has to be true for both sides, whether you're coming from the left or you're coming from the right side. Here's an example. So use the graph of h of x. So here's h of x to determine the following. So the first says the limit as x approaches 0 of h of x. So we're looking at h of x. We want to know the limit as x approaches 0. So we're talking about where x is equal to 0. X is equal to 0 right along this line right here. So in order for the limit to exist, it has to be the same from the left side and the right side. So we're looking at, as we go towards the purple side, let's start on the left side of it. So you're just going to kind of hop on the graph and you're going to ride it along. So you're coming up and you're going to say, okay, well, what y value am I approaching as I get to the purple line from the left side? Well, I'm getting to 3. Okay, well, let's hop on the graph anywhere close to this purple line, and then we'll just travel along there. We're going to come at the purple line from the right side. And what y value are we approaching from the right side? And again, we're going to 3. So as you come at that purple line from the left and the right side, they're both coming to that same point right here. They're both coming to a y value of 3. So that limit is 3. Okay, so part B says find h of 0. So h of 0 means the same thing as it always has meant. That if you put in 0 in for x, what's your y value? So it's whatever it is on the curve. So it would also be 3. All right, now let's talk about the limit as x approaches 3 from the left side. So as I hop on h of x, I'm going to find where x is 3. So I'm going to make that I'm going to find x is 3 is this blue dotted line right here. So I want to come from the left side. So as I hop on my curve, I'm going to travel towards that point. You'll see there's an open circle there. So we know we have a hole in our graph there. So we can get infinitely close to that hole, but we're never going to touch it. And actually in this graph, what happens is at x equals 3, we hop up to this solid point right here, which is at a 5. So as we approach this graph, now limits just mean what am I getting infinitely close to? Well, I'm getting infinitely close to a y value of 2. So from the left side, my limit will be 2. All right, now it says limit as x approaches 3 from the right side. So I hop on my graph to the right of 3, and I travel towards x equals 3. And as I get closer and closer to it, it again is that same y value of 2. Will I ever reach the 2 though? No, I can never actually equal 2. So what is h of 3? Well, h of 3 is not 2 this time because there's a hole there. So, depending on, you could have some type of problem where that at that value, it's going to hop up. It could just be you're graphing an equation and you have a hole, where we've talked about how you have holes before as well. So and that's, remember, if you factor it and then the two factors cancel out, then that tells you have a hole there. So at h of 3, our x value is not going to be at the hole because it's empty there. We're actually going to go all the way up to 5. So in this case, you might say, does the limit exist? So yes, the limit as x approaches 3 of h of x is the same from the left and the right side. So that's 2. But we will never actually reach that point because it's an open circle. So that will never reach the limit, but the limit does exist. Solve limits graphically. So if the left-hand limit, or the left-hand side, does not equal the right-hand limit, then the limit does not exist. So it has to be the same from the left and the right. You might be thinking of Mean Girls right now, at the end during her math competition. The limit does not exist. So number 1, use the graph of f of x to answer the following question. So really, and I know this is often a really challenging topic for students, so I want you to really just kind of take it for what it is. Don't try to make this harder than it is. We're just asking you to find a limit. Just means, what are we getting closer to? What are we approaching? What number? What y value? Okay, so for A, as x approaches -1 from the left, what is the y value of f of x? So find -1. So here's -1 right here. We want to come from the left. So I go to the left of this blue dotted line. The only graph over here is this one. So I need to travel along this one. And what am I getting closer and closer to? What y value? Getting closer and closer to a y value of 3. Okay, B says x approaches -1 from the right side. Well, if I go to the right of this dashed line, then the graph right before it is this one right here. So what am I getting closer and closer to from the right side? And to make this easier, let's just say that this open circle is right on the line there. And so that would be +1. So is the limit from the left-hand side, which is 3, the same as the limit from the right-hand side, which we just said is 1? 3 and 1 are not equal. So this is a case where we would say it does not exist because it's not going towards the same point from both the left side and the right side. What is f of -1? Well, that we can tell because we have an open circle here, so it's not that. So our closed circle would be f of -1, which is 3. So when you're finding f of -1, you always are looking for the closed point, the one that you have an actual value at, because that's the y value at that x value. All right, letter E says the limit as x approaches 1 of f of x. So let's find x equals 1 is right here. And to find that, it doesn't have a little plus or minus sign, so we need to have the left and right-hand sides be the same. And is this approaching the same point, y value, from the left side and from the right side? Yeah, it is. They're both approaching a y value of 1. And what is f of 1? Well, f of 1 is not 1 because there's an open circle right here. It's actually 2. So again, this would be a case where the limit does exist. We're approaching 1, but we'll never actually reach that limit because at f of 1, we jump up to a y value of 2. Letter G. Now we're going to look at 0. So here's 0 right here, this black line. So that's x equals 0. We want to know as we approach 0 from the left side. So we go as close as we can to the black line and what's happening to the left of that. And there's this curve here. So as we go to the left, this one is going towards infinity. It's going closer and closer. It's the asymptote is that x as the y-axis, x equals 0. So this one, we say it goes to infinity, and there are some textbooks that will use infinity. What we're going to use is follow our textbook, which says that if it goes to infinity or to negative infinity, it does not exist because it's not approaching a specific number. It's just going towards infinity. And for h, we're talking about x approaches 0 from the right side. So now go close to the black line. What's right next to it is this graph right here. So if we approach from the right side, we're getting closer and closer to a y value of 3. And we're just going to say that that meets at that line. So what's the limit as x approaches 0? Well, is it the same coming from the left and coming from the right? No, from the left, it does not exist. From the right, it's 3. So if they're not the same from the left and the right side, it does not exist. And f of 0, also, we don't know. There's no solution there. We have no y value at 0 because it's an asymptote for that left-hand side. So it's never going to touch it, never going to cross it. And there's an open circle coming from the right side. Okay, so now we're going to review graphing and also look at a table and use our calculator to figure that out. So it says, consider f of x equals x over the square root of x plus 1 minus 1. Is the function defined at x equals 0? Well, in order to be defined, we can't have a 0 in the denominator. So let's take a look at our denominator. Let's put 0 in for x. 0 plus 1 is 1. The square root of 1 is 1. 1 minus 1 is 0. So no, because x equals 0 is going to make our denominator equal to 0. And anytime we have a denominator of 0, we know it's undefined. You're never allowed to have 0 in the denominator, the one number we can't have. So let's graph it. So you can put this into your calculator. You can do it out by hand if you want to just choose some numbers. So let's go over how to put it into our calculator. So in our y equals, let's do alpha, y equals, and we have x on the top, and then the square root of x plus 1, and then arrow over, minus 1. And let's zoom 6 and see what this graph looks like. Okay, and then, so we can see right from our table here, it looks like we're starting right at -1, but let's confirm that. And I need to change my table set here. So let's start our table at 0. Actually, let's start our table at -2, and let's go up by 1s. If you start at 0, that's fine. You're just going to have to scroll. So at -2, we have an error. It looks like at -1, we're starting at our graph. So we want to choose negative value. Let's include that. A couple positive values. 3, 3 looks nice, and 8, 4 looks nice. So we're just choosing those ones that are integers. So -1, 1. And I've seen from my calculator what this is going to look like as well. So let's go ahead and graph our point. So -1, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. And then also, I know at 0, we're going to be undefined as well. So when we get to 0, we're going to have an open circle. Then it looks like it continues there. So this one should be an open circle right there. All right, so that's what our graph is going to look like. Next, we're going to use our table to estimate this value, and then we'll verify it using our graph. So to do this in our calculator, you're going to type in, which we already have done now, your y sub 1 is x over the square root of x plus 1, subtract 1 from that. And then what I want you to do is I want you to change your table set to ask for the independent variable. I'll show you what I mean right here. I'm not sure if you guys have done this before or not. So I put my Y1, we already have that in there. Now, when I go to table set, which I was at here before, don't worry about what your start and your change in table is. I want you to go right here where it says independent and change that to ask instead of auto. So what that does now is when we go to our table, so second graph, it's blank. It won't always be blank if you have done this for a question before. You just type over them. And we're going to type in the values we want. So before I go ahead and do this, I want to go back to my paper and I want to fill in what my x values I want is. So how do I do that? Well, I'm asked to find the limit as x approaches 0. So that's what's important right here is this x approaches 0. Whatever you're approaching, that's what I want you to put in the middle of your table. Okay, so whatever you're approaching, that's what goes in the middle. And now on the either side of that 0, I want you to get really close. I want us to get really, really small and really close to 0. So one thing we could do, and think of on a number line, if here's 0, to the left is going to be negatives, to the right is going to be positives. So I want these numbers that are like really, really close to 0 because I want to see what's happening as we get closer and closer to 0, infinitely close. So maybe I start with negative 0.001. And then going out further, maybe I do negative 0.01. And going out. So as I go to the left, I'm going further away from 0. And then on the right side, I'm going to do the same thing but the positives. So 0.001, 0.01. So on this side, we're getting further away from 0, closer to 1, but still we're really, really close to 0.001. And you don't have to do these. You could have done 0.0001. You could have started at 0.01 close to this. We're just trying to use these so that we can get an idea of what we're approaching. So now that you have those in, I want you to go back to your calculator and we're going to type these in. So let's type in negative 0.1 and hit enter. Once I hit enter, it gives it to me. So we're going to write that in our table. Then we're going to type in negative 0.01. And then hopefully you guys get the idea here. I don't think I need to type all of these in with you. We get that. I want these as decimals. So if you have an older calculator, it probably gave it to you as a decimal. If you have a newer calculator, you might want to set this to your answers to decimal. Should work. Sometimes there's separate table settings too, but I don't see that here. Okay, so let's go back. There we go. And now do the other 3 as well. So pause the video, do that, fill them in, and check back with me. Okay, so I'm just filling these in just so you can clearly see. Now at 0, you should have gotten an error, so we know that that's undefined. And then we get 2.0005, 2.005, 2.0488. So what I want you to look at here is what's happening as we're coming from the left and from the right. What number are we getting closer and closer to? These numbers, 1.9487, 1.995, 1.9995. So it looks like it's getting closer and closer to 2. And over here, it looks like as we come from the right side, we look like we're getting closer and closer to 2.0005, so 2.0. So it looks like the limit as x approaches 0 of f of x appears to be approaching 2. Will it ever meet that limit? And the answer, so that's the answer to the question. If I asked you, will it ever meet that limit? No, because it's undefined. So it will never actually become the point 0.02, but it will get infinitely close to it. So it will never reach the limit because it's undefined at that number. Okay. Now let's verify this on our graph. So go back up to your graph and see as you approach 0, so x equals 0 is this blue line. As I approach from the left, looks like we're getting closer and closer to 2. As I approach from the right, we're getting closer and closer to 2. But the calculator doesn't give us 2, so we didn't know exactly where to plot that open circle. But after looking at the limit, you'd know that that open circle is actually occurring at y equals 2, because that's the number you're getting closer and closer to. So that's how to do it with a table. So you just kind of match up, put the number that you're approaching in the middle of your table, and then you choose values that get really, really close. So those small decimals values to do that. All right, next we're going to talk about when the limit does not exist. So there's 3 situations when your limit may not exist. So the limits fail to exist at x equals c when. Option 1 is the one we've already talked about. If the left-hand limit does not equal the right-hand limit. Option 2, if f of x approaches infinity as x approaches c. So we briefly talked about this one on that first question, part G, where we said the limit did not exist because the graph was going towards infinity. So anytime it approaches infinity, the limit does not exist. And then the last one we have not talked about, and this one doesn't come up quite as often, but this one says that if it's oscillating. So think of like a sine or cosine curve. If you're going back and forth between 2 numbers, you're oscillating between them, going up and down. Think of a fan, it's cyclical. Then your limit also does not exist. So number 3 asks us to graph and show that the following limit does not exist and justify your answer. When I say justify your answer, I want you to give me one of those 3 reasons as to why it does not exist. So we want to graph this. So we can come up with a table first. So you can feel free to put this in your calculator, or I'm going to just substitute in. I want to make sure I have negative and positive values. So if I sub in a -4, that's the absolute value of -4 over -4 is +4 over -4, which would give me -1. -3, absolute value of -3 is 3 over -3 is -1. If I put it -2, absolute value of -2 is 2 over -2 is -1. Hopefully you're seeing the pattern here. What happens at 0? Well, at 0, you have an x in the denominator, so it'd be undefined at 0. All right, now let's do some positives. So if I put in a 1, absolute value of 1 is 1 over 1 gives me 1. 2, so the value of 2 over 2 is 1, and hopefully you're starting to see the pattern. No matter what positive number we put in, we get a 1. No matter what negative number we put in, we get a -1. Let's graph it. So -4, 1, 2, 3, 4, we're at -1. -3, -1, -2, -1, -1 would be -1. And then 0 is undefined. And this is going to go on forever towards the left. And then we have the point 1, 1, 2, 1, and then we know that's going to continue. Again, at 0, that's undefined. All right, so we want to know what's the limit as x approaches 0. So here's x is 0 right here. If we come from the left-hand side, our limit is what y value are we approaching? We're getting closer and closer to 0, or to -1. And as we come from the right-hand side, our y value that we're getting closer and closer to is positive 1. So the limit as x approaches 0 from the left is negative 1. The limit as x approaches 0 from the right side is positive 1. So this does not exist because the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right side. So the left-hand limit and the right-hand limit are not the same, therefore it does not exist. Next, given the graph, and this one was already graphed for you, determine the limit as x approaches 0 of this. Okay, so if we want the limit as x approaches 0, here's x equals 0 right here. So from the left-hand side, we're getting closer and closer to positive infinity. And from the right side, we're also going towards positive infinity. So they are approaching the same thing. They're both approaching infinity, but anytime it approaches infinity, we're going to say it does not exist because it's not a specific number. So yes, they are going in the same direction. Yes, they're going towards infinity, but anytime they are both going towards infinity, or one infinity and one negative infinity, it still does not exist because the limit as x approaches 0 of 1 over x squared approaches infinity, which is not a real number. So that's why we say it does not exist, because infinity is not a real number. So yes, it's approaching the same thing, but it's approaching something that's not a real number. So it does not exist. So that was option 2 in our box above. And the third one, you can probably guess since we've done the first two. It says fill in the table. So what I'd like you to do is go to your calculator, type in your y1 is sine of 1 over x. Since I see all these pi's here, I want to put my calculator in radian mode if it isn't already, and I'm going to change the independent to ask. So let me bring up my calculator, go to my y equals, type in sine of 1 over x, and let's check here. I'm in degree mode, so I'm going to switch it to radians. Second table set, I'm already at ask. So now you'll see they already have numbers in there, so you can reset your calculator to clear them out, or you just type right over it. So I'm just going to type in 2 divided by pi and hit enter. Then I'm going to type in 2 divided by. Now be really careful here. I don't think it lets you do alpha y. Oh, it does. So I would do that if you have these newer calculators. If not, I'll show you what to do on the next one. So for the next one, if you don't have a calculator that's letting you do alpha y equals at home right now, then you would need to do 2 divided by, oops, and then in parentheses, 5 pi. So this is very, very important. You cannot just type in, let me show you, let's type in 2 divided by 3 pi again. Now it gives me a totally different answer because it's order of operations. It's doing 2 divided by 3 and then multiplying 2/3 by pi. We want to divide. So here, let's do 2 divided by 7 pi. Again, it has to, 7 pi has to go in parentheses. And then easiest way is going to be to do alpha y equals. So let's do 2 over 9 pi. So practice typing these in on your own. It's really, really important, and see what happens. So here, and you'll get these decimals. There's no way to keep those as pi's. In your table, we got 2 over pi is 1. 2 over 3 pi is -1. 2 over 5 pi is 1. -1, 1. Then that one should have been -1. So this one is just going back and forth between 1 and -1. So as x approaches 0, that limit does not exist. And the reason for that one would be because it oscillates an infinite number of times. So that's why that limit does not exist. So 3 reasons why your limit could not exist. Number 1, the left-hand limit is not the same as the right-hand limit. Number 2, it approaches infinity. And number 3, it oscillates. So it goes back and forth. The last part is how to solve limits, and that's using direct substitution. So this part is actually probably the fastest part of the whole lesson and probably the most concrete to understand. So to find the limits, all you have to do here is for direct substitution is you take whatever your limit is approaching and you sub it in for x. So this would be the tangent of pi divided by pi. So I would want you guys to be able to do this without a calculator. But of course, you have your calculator at home to check. But we know pi is over here on our unit circle. So pi has an ordered pair of -1, 0. We know tangent is sine over cosine. So sine over cosine in our ordered pair, it's cosine comma sine. So our sine is 0, our cosine is -1. 0 divided by anything is 0. So this gives me 0 over pi. 0 divided by anything is 0. So this limit, if you were to graph tan x over x and look at pi on your x axis, both the left-hand limit and the right-hand limit would be approaching 0 for y. All right, the next one, limit as x approaches 2. So again, what we're going to do is take out the x and put in a 2. And then you can type it in your calculator, but I'd like you to try to do it without. Do your order of operations. So 4, 2 to the cubed, 2 to the third, or 2 cubed is 8. 4 times 8 is 32, plus 1 gives me 33. So 33 is my limit as x approaches 2. Letter C. Again, just substitute in pi over 2 everywhere you see an x. Again, I would like you to be able to do this without a calculator. So find pi over 2 on your unit circle. The ordered pair there is going to be 0, 1. So cosine and sine, C comes before S in the alphabet. So pause it here would be a good spot. See if you can finish this one. Also continue on to D and do that one on your own, and then check back with me. All right, so you should have found that the sine of pi over 2 is 1, and the cosine over here is 0. So 1 would be your final answer. So as x approaches pi over 2 of sine x plus cosine x, it would give you 1. And the last one, you should have substituted in your 5 everywhere you see an x. So we get 6 times 25 over 10, which should have given you 15 for your final answer. Okay, and that is all for today's lesson. Let me know if you have questions. I know it's a hard concept to grasp, these limits. All right, I hope you're all staying healthy, having fun, math dancing up a storm, and I hope to see you soon. I miss you guys. Pi out.